Question number 5. It is given ABCD is a parallelogram, and then also it is given this distance BQ is equal to BD. These two distances are equal, and in the first part you are asked to prove that triangle APD, this triangle APD congruent to CQB. CQB is this. So the first part is to prove these two triangles are congruent. Proof. Which triangle? In triangle APD, this triangle APD, this triangle, and this triangle BQC or CQB. In these two triangles, what we have, you see, this distance AD is equal to BC. AD is equal to BC. Why? Because they are opposite sides of parallelogram. You will mention here opposite sides of parallelogram. It is mentioned ABCD is a parallelogram. And then BQ, distance PD is equal to BQ. PD is equal to BQ. It is given. And then this angle equal to this angle. They are alternate angles. It is like this. This is BC, this is AD, and this is the transversal. So these two angles are equal. That means this angle equal to this angles. So you can just give the numbering here. This is angle 1, this is angle 2. It will be easier to understand and shorter in writing. Angle 1 is equal to angle 2. So what we got? By side angle side criteria, you see, side equal to side, side equal to side, angle equal to angle, and side equal to side. Angle is in between the sides. Okay, that means by side angle side criteria, the two triangles are congruent. It is written here, triangle APD is congruent to triangle CQB, and this is the complete proof of the first part. The second part is to prove AP equal to CQ. AP equal to CQ. So this, you see, we already have proved this triangle and this triangle are congruent. Already we have proved in the first part. In one, what we have proved? Triangle, it is here, triangle APD is congruent to triangle CQB. This implies corresponding AP must be equal to AP equal to CQ. AP is equal to CQ by CPCT. And this is the proof of the second part. The third part is to prove triangle AQB. The same diagram I have drawn again just for convenience to make it easier. AQB, this is triangle AQB, this triangle and this triangle. We are asked to prove these two are congruent. Now you see here, we can mention here which triangle we are considering. AQB triangle, and another is triangle CPD. This triangle and this triangle, you see. The first condition we have is AB equal to CD. They are parallel, opposite sides of parallelogram. AB is equal to CD. You will mention here opposite sides of parallelogram. Then BQ is equal to PD. It is given. BQ is equal to PD. It is given. And you see this angle equal to this angle, because they are alternate angles. This angle and this angle, they are alternate angles. It is like AB here, DC here, and it is like this transversal, AB, DC, BD is transversal. So these two angles are equal, alternate angles. You can mark here angle, say 3 and 4. So angle 3 equal to angle 4. How? You will mention here they are alternate angles. The diagram it is shown here. And then what we are getting? We are getting side angle side. You see, angle is in between the two corresponding equal sides. This side equal to this side. Okay. So angle is in between the two sides. So it is by side angle side criteria. Side angle side criteria. You can say these two triangles are congruent. Triangle AQB, it is written here, AQB congruent to triangle CPD. This is the proof of the third part. And the fourth is here, to prove AQ equal to CB. AQ equal to CB. To prove AQ is equal to CB. And we have already proved this triangular congruent. You see this one, this is the one we will take. We have already proved triangle AQB congruent to triangle CPD. So here you see AQ corresponding equal. This implies AQ equal to CP by CPT CP corresponding parts of congruent triangle, like AP equal to C, AQ equal to CP. And you can also write the corresponding other sides, QB is equal to PD or AB is equal to CD, like that. So we have written here just AQ equal to CP, which you are asked here. So this is the proof for the fourth part. The fifth is to prove APCQ is a parallelogram. APCQ, this diagram, APCQ, parallelogram. And here you see you have already proved this side. We have already proved AP equal to QC. AP equal to QC. We have already proved from the previous parts, first and the third part. Okay. AP equal to, so it was in the second. AP equal to CQ, second part and fourth. AP equal to CQ. Already we have proved. Then already we have proved also AQ equal to PC. We have already proved. So what it is in this triangle, opposite sides are equal. In this quadrilateral, that is in quadrilateral. Which quadrilateral? AQCP. This quadrilateral AQCP. What you are getting? You are getting AP equal to QC. Opposite sides equal, and the other pair also opposite sides are equal. Pair of opposite sides are equal. And therefore it is a quadrilateral. It is a parallelogram. What you will write here? You will write here, in this quadrilateral, pair of opposite sides are equal, which we have written here. Pair of opposite sides are equal, and hence it is a quadrilateral. And this is the complete proof for this question.